So this is Unit 6, Trigonometry, Day 4, Solving Triangles. Basically, we are pretty close to being in the later part of this unit. You can expect your quiz to be on the later part of this week and hopefully get your test done this week as well. Now, as far as what we're doing today, we're going to see basically three kinds of problems. So we're going to do three examples. The first of which we're going to be finding a missing angle measure. So pause the video, get sketched in your notes really quick, and I'll show you how to do it. What's going to happen here is it says find the measure of the angle indicated. They're actually using a variable called theta, so they're using a Greek letter to instead of an x. The only reason why I'm doing that is because it's what happened on the worksheet, but really this operates the same as a x or any other variable you've ever used. All right. First thing to do is go around the triangle, label your sides. So I always start with my hypotenuse, which is always across from 90 degrees, which is the 15.3. Next, I'll label my opposite leg and my adjacent leg. So opposite of the angle is the 10, and my adjacent leg has nothing on it, so it's not a part of the problem. So when I write out my phrase, SOH, CAH, TOA, which we've covered before in this class, what you're going to do is look for the function that you would be able to use. Since there's no A, it's not going to be CAH, nor can I be using TOA. Since it's a hypotenuse and opposite, I have to be using the sine function, SOH. So we'll set up sine of my angle equals the ratio opposite over hypotenuse. My angle here is theta degrees. And if you use an x here, that's really not a big deal to me. That's fine. I'll now do opposite over hypotenuse, so it needs to be 10 over 15.3. Now, I have one step to do. When you're looking for an angle measure, remember this is when you use the inverse of your trig function. So theta equals. To move sine over to the other side, I will do sine inverse of 10 over 15.3. Now I'm ready to type this in my calculator, whether it be a TI or the Desmos calculator. Really doesn't matter what you're using. I'll probably be using a Desmos on this. Alright, you can see I grabbed my Desmos calculator. You can be using the Texas Instruments calculator. Just check your modes in degree. Here I'm going to tap on functions and then look at sine inverse and type in 10 divided by 15.3, and I'll get my final answer of 40.8 degrees to the nearest 10th. So that's my answer on this problem. And I'll put approximately. Alright, there's my answer and how I did it. Alright, this is example 2. Please again pause the video to record this in your notes. Alright, now the difference on this problem is we are finding a side. When you're finding a side, right now you got two tools that you might use to find a missing side. You'll either use Pythagorean theorem or you'll use sine, cosine, tangent as of right now. In this case, since the problem involves an angle and two sides, you're going to use sine, cosine, tangent. I'll show you a case where you would want to use Pythagorean theorem on the last example, example 3. So since I'm using sine, cosine, tangent yet again, just like I did on example 1, I first need to go around and label the three sides of the triangle. So across from my right angle is the hypotenuse, which is x. So hypotenuse is involved on the problem. I already know it's not going to be tangent since hypotenuse is part of this problem. So I might go ahead and X that off already. Next, I got to figure out which leg is opposite, which leg is adjacent. Look at the 64 degrees. BC is my opposite leg from 64 degrees. 8 would be known as my adjacent leg to 64 degrees. So, since adjacent has 8, I know I'm going to be using cosine because that uses adjacent and hypotenuse. Sine would have needed the opposite leg, which is not involved on this problem. That's also, again, why a tangent was not used. So I'm going to be using the cosine function on this problem. It'll be of my angle, and it'll equal the ratio adjacent divided by hypotenuse. Now I'm going to go ahead and get started with filling things in. Go ahead and put in your angle of 64 degrees. Now we need to make our ratio of adjacent divided by hypotenuse, which will be 8 divided by x. It's really a 50-50 chance on whether x is going to be on the numerator or denominator. Regardless of where it is, you should always, on your next step, multiply by the denominator, which in this case is x. So I'm going to multiply both sides by x. So on the left side, this is going to be x times the cosine of 64, which is some number. And on the right-hand side, 8 divided by x multiplied by x, that's just going to leave an 8 because the x is canceled. On my last step here, I do have to divide both sides by the cosine of 64. So that cancels on the left side and leaves me with just an x. On the right hand side, I have 8 divided by cosine of 64. Now, I'm ready to use my calculator to actually calculate this value. So you can see where I've already grabbed my calculator. I'm going to clear out what I did before, and I'm going to type in 8 divided by, again, to get sine, cosine, or tangent, you tap on functions and tap on cosine, the second one on the left. 64 degrees. And I get 18.2. I was supposed to round to the nearest tenth, the problem said. So x is approximately 18.2 units. I look in context of the problem, and that seems pretty reasonable. It does need to be longer than 8. So this is my final answer. Alright, here's the last example on this lesson about solving triangles, specifically right triangles. This is a Pythagorean theorem problem, and I'll explain why that is in just a second. But as you're recording this, know that this is a B, not a 6. So go ahead and record that in your notes. Alright, next thing I'm going to do is identify what I'm doing. As I've already said, this is actually a Pythagorean theorem problem. So as I look around this triangle, there's no mention of any angles. That's my first cue that I'm actually doing Pythagorean theorem. Secondly, you'll use Pythagorean theorem when you already know 2 sides and you're looking for the third side. That's the cue that you're using Pythagorean theorem. So I'm going to go ahead and write down a squared plus b squared equals c squared. Alright, next, I'm going to fill in anything that I know. C squared. Well, c is always the hypotenuse. So I know the 9.5. I'll consider 5 to be a. That way b can be b. Alright, so I'm going to go ahead and label this as a. This is c. And like I said, it's easier if I just make b, b. So 5 squared plus b squared equals 9.5 squared. Alright, pretty straightforward so far, and I would definitely expect y'all to probably be using a calculator for these calculations. Just makes it a little bit quicker, but something like 5 squared we know is 25. And now I'll do 9.5 squared. And I'm going to get 90.25. I know that didn't show up due to the glare. 90.25. Next thing I'll do is I'll subtract 25 from both sides of the equation. So b squared is equal to, I'm just going to continue that in my calculator. When I subtract 25 from both sides, I get 65.25. And on my last step, I'm going to square root. As a reminder, I do not need to do positive or negative square root on both sides. Since I know that b is a measured distance, it's not going to be the negative square root. So now, here's the difference from Friday. On Friday, I expect you to give me a simplest radical answer. On today's lesson, I'm going to be all right if you just round to the nearest hundredth. Just a little bit of a change in instructions, so always just follow those instructions as you see them. So what I'm going to do is just grab my calculator here and let it crank out the work. I'm going to simply type in square root, which as a reminder on the Desmos is down here at the bottom, 65.25. 8.08 would be to the nearest hundredth. That was a little bit different because on the other problems we were rounding to the nearest tenth. This problem said round to the nearest hundredth, so 8.08 would be rounding this correctly to the nearest hundredth since it was a 7 after this first 7. And that's my final answer on this last example. All right, so there's 3 groups on the assignment of problems, and the 3 examples I've done does a similar problem that will guide you in how to do these problems on your assignment. Good luck. I'll take that up. You can turn in at the end of the period. Please check over your answers, and I'll answer questions tomorrow. Thank you very much.